Hey guys, so we're starting 9.2. We're looking specifically at angles in radians and degrees. All right, and so to help us first, instead of me writing on the paper, I think we're going to use this right here. This will probably make more sense. So this really confusing looking circle is called the unit circle. Unit circle. Really important for you to know and have. Now I just kind of did a quick Google search and came up with this one. It's not the one that I normally use, but I had to trade out my tablet recently, and so I don't have the one that I normally use with me, but this one works just as well. You can do a Google search and find either this one or another one you like better. They all work the same way. So it's a circle, goes around a circle. I'm going to start, the unit circle starts right here. So we don't start at the top of the circle, we start on the right of the circle, and it moves this direction. We move counterclockwise. We start right here on the right, start right here, and we move counterclockwise around our circle. And if you look at the inside part of my circle, you'll see degrees. Well, from here to here, that's 30 degrees. And we're okay with that idea. From here to here is 40 degrees, 60, and then of course there's 90. I could draw a little box and say, oh, yep, there's 90 degrees. And then I just keep going around my circle in degrees until we get back to 360, because 0 and 360 degrees are really the same. I mean, they put me in the same spot. Okay. Now, once you're okay, you look at that and you realize, okay, I understand how degrees works. That makes sense. I see that. Then we can understand how radians work. So my outer circle, let's see if I can do this without this being too complicated. So this outer circle, those ones with all the pi's in them, all right, yeah, those out there, those are all radians, okay? Well, note that pi radians is the same thing as 180 degrees. Well, if 1 pi radians is 180 degrees, and 90 degrees is half of 180, well, 90 degrees has to be half of pi. So right here, I get 90 degrees is pi over 2. And then if I did half of 90, I'd be at 45, and half of a half is a fourth, okay? And so, and if I doubled 180, I would get 2 times pi, which I get right here. 2 pi is 360, okay? So radians is just another way of dividing out my circle. And it actually, in some ways, makes more sense. Think about circumference. Circumference is the distance all the way around the circle. Well, what's the equation for circumference? It's that right there. It's 2 pi times the radius. Okay, circumference, the distance all the way around the circle, is 2 pi times the radius. Okay, and this is exactly where we get the 2 pi from our circumference formula. Okay, so you've actually been using radians before without even realizing it. Okay, so for our purposes today, we need to know where are radians at, understand the measures, and be able to go back and forth, which we can do. All right, so with all that being said, now let's actually look at our problems. So we'll pull up the first problems. All right, let's see, zoom in a little bit. It says draw an angle with the given measure and standard position. All right, number 1 says 170 degrees. So I'm going to keep going back here. We're doing 170 degrees. Number 1, 170. So I'm going to use this right here. We'll change the light. Best I can, I'm going to draw an XY axis. And then I'm going to try to draw the line. 170. 170 is almost 180. So again, my angle starts here, okay, and then it goes, so this would be 0. If I keep going about 45, 90, and if I keep going, this is 180, so just a little bit less than that. That right there would be 170 degrees. I'll put a little line here to show There we go. So that's what I would do for number 1. See if I can take those off. There we go. Let's look at number 2. Number 2 is 540. Okay, 540. That's more than all the way around my circle. Okay, so let's pull up my calculator, which I don't have on this unfortunately right now. Oh, you know, I can pull it up. Let me just get my calculator. There we go. This one right here will work fine. Let's see, what's 540 minus 360? 180. Okay, so that means 540 goes all the way around the circle, one time, and then goes another 180 degrees. Okay, so if I pull my little annotate out, let's see here. We're on number 2. 540. Okay, so if I start my arrow here at 0, it's going to go, the next one's going to go all the way around the circle, 360 plus another 180 degrees. And to show that, I'm going to take my little arrow here and say, oops, wrong thing. There we go. So it goes all the way around the circle and then comes back right there. So that's how I show 540 degrees. There we go. All right, and let's look at the next one. The next one says negative 80. Well, negative just means I go the opposite direction. So annotate, negative 80 degrees. Well, again, normally we go clockwise. Negative just means I'm still starting at the same point, but instead of going counterclockwise, I go clockwise. So negative 80 would go this direction, and 80, well, there's 90 degrees. 80 would be just a little bit less. Not being like super precise, so there you go. That angle right there, there would be negative 80. Okay, let's move on to the next one. We now get some radian ones. I see 5 pi, 2 pi over 3. I'm going to write these down so I can just copy them. 5 pi, 2 pi over 3, negative 3 pi over 4. All right. Well, keep switching back. All right, so the first one we're going to do is 2 pi, or sorry, 5 pi. 5 pi. Well, let's look at our unit circle. I see that if I go here, that's 1 pi. We go around all the way, 2 pi. Well, let's think about this. I'll do that a little bit. Let's try this. Yeah. So if I'm going this, that's 1 pi, 2 pi, then that would be 3 pi, that would be 4 pi, and that would be 5 pi, because really each pi is just 180 degrees. So I'm doing 180 degrees 5 times. So I want to go 1, 2, 3, 4, 5 times. So let's see here. How would I actually draw my arrows? Well, there's my first one. So we went around 1 pi, 2 pi, 3 pi, 4 pi, and then back here for 5 pi. That would be 5 pi. All right, next one is 2 pi over 3. Here's another reason why it's really nice to have my unit circle right here. 2 pi over 3. I see 2 pi over 3 on my unit circle right there. So I can use that and say, oh, there it is. Again, got to start here at 0. And then using my unit circle, I see, oh, it's the same thing as 120 degrees. So it's about a third of the way right there. So there we go. There's 2 pi over 3. Okay. The next one is a negative, so we're going to go backwards. It's negative 3 pi over 4. All right, well, let's look at my unit circle. Where's 3 pi over 4? 3 pi over 4 is right here. It's 135 degrees. But this is assuming that I'm doing positive. Well, if I went that far, but I went there in the negative, well, then I would go backwards 135. I'd go that far. So I'm going to switch here. I'm going to say, okay, well, I still got to start at 0. But instead of going this way 135 degrees, I'm going backwards 135 degrees, right about there. And it's going to look like that. Okay. And there's my angle. And that's the end of that first section. All right. It says match the angle with the given, or match the angle, measure with the given angle. Okay. So let's look at these. I want to cheat just a little bit and look at number 9 first, because I see it's negative. Well, it's negative, meaning it goes backwards. Well, how many of these go backwards? Well, only one. So this has to go with that one, okay? Because it's the only one that goes backwards. All right, well, then I'll say, okay, well, 500 degrees. 500, well, that's more than 360. How much more than 360? Let's find out. So 500, wrong button. There we go. 500 minus 360. So it goes all the way around the circle one time and then 140. So let's draw that off to the side, what that would look like. Quickly, so if I had, oh my goodness, sorry. All right, I thought I could do this without the arrows. I cannot. Wasn't even that straight with the arrows. All right, so if we're going to do this 360 plus 140. 140 is, well, there's 90. And so 140 would be somewhere right about there. Okay. Which one looks like that? Well, B does. So this one right here has to go with B, which means that 7 pi over 3 has to go with A. Okay. It says find one positive angle and one negative angle that are coterminal. Okay. Coterminal means they end in the same spot. Okay. This is actually super easy. All we have to do, let me explain what we're doing. Maybe draw a picture, it'd be better before I get too far into my explanation. So let's see here. So let's start off with the first one. The first one's 75. 75. All right, 75 degrees is roughly about here. I need to change colors there. Try that again. There you go, right about there. 75 degrees. Well, if that's 75 degrees, what's another angle that ends up being the same spot? Okay, so there's 75 degrees. Well, if I go all the way around my circle and then come back to that same spot, I would still be in the same, it would be a different angle, technically, the measure would be, but I'd still end up in the same spot in that it would still be coterminal. Likewise, instead of going forwards, I could go backwards and get to that angle. I would just have a negative angle. Well, how do I figure out what those other two angles are? Well, all I have to do is add and subtract 360. So to find my two angles, we're going to say 75. We'll find the positive one first. So plus 360, 435. So my first answer, annotate 435 degrees. Okay. Well, what about the one that's negative? So let's clear that out. We'll do 75, but this time we'll subtract 360 degrees, and I get negative 285. So negative 285. Those would be my two angles. Okay, do the same thing with number 11. Number 12 looks a little different. That's because instead of adding and subtracting 360, we now need to think, well, 360 is the same thing as 2 pi. So I'm going to clear this out. Let's see, there we go. Clear out. Okay, we also just saw 7 divided by 3. 3 goes in there more than 2 times. So this is actually more than, this right here is greater than 360 degrees. So because of that, we need to subtract 360 degrees, or 2 pi, and then that will still give me a positive answer, and then I'll have to subtract it again. Okay. So how do we do that? Well, instead of subtracting 360, I'm going to subtract 2 pi. Okay. Well, let's think about this. I have a fraction and then a whole number. I really want to be able to subtract fractions. I need them both to be a fraction. So I need to say, well, this is going to be over 1, and then I'm going to multiply top and bottom of this fraction by this denominator. So I'm going to multiply top and bottom by 3, giving me 7 pi over 3 minus 2 times 3 is 6 pi over 3. If I subtract now, I get 1 pi over 3. Notice that is a positive number. So even though I subtracted 2 pi, which is really 360 degrees, I got a positive number. So I'm not going to add 2 pi to the original. I'm going to subtract 2 pi again from what I just got. So I'm going to say pi over 3 minus 2 pi. Okay, I'm going to write 2 pi up here because I know that I'm going to have to change it to a denominator, and that's going to be the denominator I'm going to change it to. Okay, so 6 pi over 3. Now I get 1 pi minus 6. 1 minus 6 is 5, but negative. Negative 5 pi over 3. And there's my two different angles that satisfy number 12. All right. Now, can I convert back and forth between radians and degrees and degrees and radians? And the answer is yes, I can. Okay. And for this one, I will actually use my piece of paper. So let me get my little lamps turned on so you can see my piece of paper. All right. Start up. All right, so I'm going to write down our values. So we have 225 degrees, 50 degrees, negative 160 degrees, and then we switch to radians. We have pi over 12, 5 pi over 9, and then negative pi over 8. Okay. All right, so this is our first one we have. Now, remember that 180 degrees, all right, it's off the side, 180 degrees is the same thing as 1 pi. All right, we saw that from our unit circle. That's super important. We're going to use that because I'm going to multiply these, this one right here, I'm going to multiply it by 1 pi over 180 degrees. Now, 1 pi and 180 degrees, we just said are the same thing. So technically, whenever something's over itself, that's 1. So technically, all I'm doing is multiplying this by 1, which doesn't change it. But this allows me to convert from degrees to radians because my degrees symbols are actually going to cancel out, and I'm going to be left with radians. So I'm going to change that to over 1, multiply across, 225 times 1, 225 pi over 180. And now I'm just going to simplify. So let's think about this. What divides into both of those? Well, 180, I know is divisible by 5. 225 is divisible by 5. And so if I divide them both by 5, that gives me 45 pi over 36. And you'll notice that when I'm doing this, I just leave the pi there. It's not going to go anywhere. I'm just worried about the numbers. All right, so now I see 36 and 45. Oh, well, I know both of those are divisible by 9. This 45, if I divide it by 9, 45 is 5. 36 divided by 9 is 4. So that simplifies to 5 pi over 4 radians. So this is degrees, and this is exactly the same thing, but in radians. Okay? All right. Let's move on to the next one. Trying to adjust my lamp so you can see a little better without the lamp actually just popping on the screen. All right, that's even better now. All right, 50 degrees. You're going to do exactly the same thing. Multiply it by pi over, or 1 pi over 180. Okay, when I multiply, I get 50 pi over 180. Well, 50 and 180 are both divisible by 10, so I can just really divide them both by 10, which really just cancels out that 0, and I get 5 pi over 18. That pin's down on me. 18. And that's as simplified as that one's going to get. What about this one? This one's negative, which makes no difference whatsoever. The answer is going to be negative, and that's it. I'm just going to leave the negative out front. So multiply. I get 160 pi over 180. Make sure I tack my negative on. Again, I can divide by 10. That cancels those zeros out, and I get 16 pi over 18. I can divide both of those by 2, giving me 8 pi over 9. All right. Well, can we go backwards? If I have radians, can I convert from radians to degrees? Yes. I just need to flip my fraction. So instead of doing a pi over 180, I'm going to do 180 over pi. I do that because before I wanted my answer to have pi on top because my answer is going to be radians. Here I'm trying to get rid of the pi. So I want those pi's to now cancel out. So now I have 180 over 12. Well, I'm going to type in that in my calculator. 180 divided by 12, and I come up with 15 degrees. All right. How about 5 pi over 9? We'll do the same thing. I'll multiply by 180 over pi. Well, let's see here. What is 5 times 180? 5 times 180, 900. 900 divided by 9. Of course, the pi's cancel out. Well, 900 divided by 9 is just 100 degrees. All right. And then that's our last problem. We have negative pi over 8. Well, just like before, the negative doesn't change anything. The pi's are going to cancel out. I got negative 180 divided by 8. So 180 divided by 8, and I get negative 22.5 degrees. And that is it for 9.2.